class 17 lab talks to, we're gonna show the characteristics of a capacitor that can block the DC voltage, okay? Before I do that, I have to measure the capacitance of the capacitor here. So I have, this one level was 470. When I'm measuring it, I'm getting 480 microfarad. How do you measure it? So you bring your dial to the capacitor measurement here. Then this is the yellow, right? So you have to press the yellow button to make the capacitance. If I don't press the yellow button, I don't get anything, right? So press the yellow button, then you'll get the capacitor measurement. Oh, now it's showing 470, 477, 479. I'll take 480, okay? So that's measurement here. So I'll take 480. I'm gonna record that measurement over here. 480 microfarad. So now, capacitor has, electrolytic capacitor has the polarity. So again, longer lag is the positive, shorter leg is negative. If you cut them equally, you'll see the negative sign over here pointing to this side. So that means it's showing the negative is in this side, okay? All right, so I'm gonna put positive to positive here and negative to negative here, right? Then I have 1 kilo ohm resistor going from that point to the reference. So I have capacitor, resistor, I make this circuit. Again, I'm measuring input here, output here, right? So this is my input. My input has this. My input has 2.5 kilohertz sine wave and 1 volt peak to peak, 2 volts offset. What this means that you have a 2 volts offset here. Like if you don't have the offset, your sine wave should be here, right? Because of the offset, your sine wave would be riding on the offset. So your sine wave uplifted over here, and you still have the 1 volt peak to peak. So on the top we show 2.5, in the bottom we should show 1.5. Still have 1 volt peak to peak, but is riding on 2 volts, not 0 now. But this, it is the input, right? This DC blocking capacitor here should block this 2 volts DC, and output, it should come to 1 volt peak to peak. Your positive peak should be 0.5 volts, negative peak should be negative 0.5 volts. So if your capacitor blocking the DC, which is 2 volts, I'm applying from the single generator, your output should be 1 volt peak to peak still, but reference comes down to 0. All right? Let's see what happens here. Okay? So now I need to make this one sine wave here, sine wave, right? 1 volt peak to peak. My frequency would be 2.5 kilohertz. So 2.5 kilohertz right here. All right? Then offset, and the offset is 2 volts, right? 2 volts DC. That's all my setup here. So I'm gonna turn that on. That's my input coming in the input side over here. Then at the output level here, let me see what I have here. So I'm gonna show both input and output. Come on, wake up. Wake up. What happened? Oh, it's coming. My oscilloscope is waking up, so all right. So now I'm gonna press the auto scale here. So let's see what's happening. So now, who's on channel 1? My channel 1 is this one. The top one is channel 1. Can you see that? So now let's adjust the frequency. I can see them better. So now, where is the reference? I'm gonna put the reference over here and make it like that, right? And also this one, both are at, I'm doing for the, both of them here, can I say channel 1, channel 2, 2 volts per unit. So they're same scale, right? This is my reference here. This is my reference right here for channel 1. Can you see that? So each of the block over here is showing, let's see here, what's my reference for channel 2? Channel 2 reference, let me see. All right, that's good. So this one, this one riding on a voltage of 4. Why is that? It's a mismatch, called mismatch of my impedance of this circuit. This circuit impedance mismatch with my signal generator. I can fix it. Let me fix it over here. So I'm going to go utility, set output, high load G here. So that should do it. Then I have the 4 volts now. I have to fix it to 2 volts DC now. All right. Then let me see what is my amplitude. It's 2 volts. I have to go to 1 volts now. Let's do that. Frequency should not change. All right, good. So now look at here. Let's see. So if you look carefully over here now, 1 volt peak to peak, offset is 2 volts, right? So each of the block is representing 2 volts, right? So this one input is riding on a 2 volts DC voltage, right? And is reference right here, and is one up here, right? So it's riding on 2 volt DC. But if you come back over here now, look at that, your channel 2, which is the output across the resistor over here after the DC. Can I give it over here? So so look at here. So input has a 2 volt offset. Your signal is riding on the 2 volts offset. You can see on the oscilloscope right here. There's 2 volts right here and riding on 2 volts. And output over here, the reference right here. Look at the output over here. No DC offset because DC is blocked by the capacitor. So DC is gone. Now here's a 0 reference for the output. That's the Q over here. So now if you all the measurement over here, your partner will do the measurement, and you should have the measurement from your partner. Okay. So if I measure minimum voltage for channel 1, so if I go to measurement over here, let's see what is the measurement. Quick measurement. If I go, let's not do the quick. So source, let's make it source 1, all right? And measurement, let's say we're gonna do, so let's go peak to peak. You can go up and down here, or you can use this. We're gonna go minimum voltage, minimum right here. I'm gonna do one measurement. No. Minimum measurement. So your minimum is showing 1.61, right? Right here, can you see the minimum is 1.61 right here. It's ideally show 1.5, but it's showing 1.6. That's the 1.6 for me. Then you can go and take the max measurement over here. So go up and take the max. Max is showing 2.559. So if you subtract from each other, you should get 1 volt peak to peak, right? So again, basic thing is that take the quick measurement out of here. The basic thing is that signal 1 has a 2 volt offset, so the signal 1 input signal is riding on 2 volt offset. Signal 2 doesn't have that offset because your DC blocking capacitor blocked that DC. You have now there's no DC offset. It came down with 0 reference. That's the goal here for DC blocking circuit. And all the measurement for this lab, you should get it from your partner. All right, that's all for this task.